Okay, so the last question here is, this is question number 11, part 7. This is question 11, part 7, which is you want to find the derivative of f of x is equal to 2 times tan x minus 7 times secant x. So this is a little bit, I did solve this problem on my own, but now this basically the answer is supposed, since they have gotten the answer in the book in some specific form, I want to get the answer in the same specific form, meaning that they have gotten f prime of x as basically 2 times secant squared x minus 7 times secant x tan x, and I want to get the answer in this particular form. Otherwise it's possible to get in any other trigonometric form that you want, really, because you can divide, for example, certain things by certain trigonometric ratios and get the answer in different functions. So I'm going to do this based on the solution then, so that you get the answer in that exact form. Right, so now one thing that we need to first calculate is we need to know what is the d by dx of tan x. D by dx of secant x, I suppose we have already calculated. We know that d by dx of secant x is equal to secant x tan x. That we already know. But d by dx of tan x, we have not calculated yet. So we will calculate that first, and then we will see about the rest. So I'm going to calculate d by dx of tan x here, and then we will get back to this question. So if your function is f of x is equal to if your function is equal to tan x, then basically since we don't know what is the derivative of this function, I'm going to need to calculate this based on the first principle. And so f prime of x is equal to the limit of basically f of x plus h minus f of x over h as h tends to 0. And basically you can write this as the limit of f of x plus h would be tan of x plus h minus f of x would be tan x divided by h as h tends to 0 . Now tan x, you can write it as sine x by cos x, so that's sine of x plus h over cos of x plus h minus sine x by cos x divided by h as h tends to 0. And then you can simplify this a little bit, meaning that you can write, for example, you can write it as the limit of, take LCM here as cos of x plus h times cos of x, and then if you just simply add, you will get basically cos sine of x plus h times cos of x minus cos of cos x plus h times sine x, and then you can divide this by h as h tends to 0. So this is the same thing as sine x cos y minus cos x sine y, sine x cos y minus cos x sine y, which is equal to sine of x minus y. So therefore I can write this expression, I can write it as sine of x minus y. So this becomes x, this becomes y, so that's x plus h minus x, which is equal to sine h. So this numerator becomes sine h. This denominator, I can write it down here, meaning that I can write this as the limit of sine h over cos of x plus h times cos x times h as h tends to 0 which is the same thing as the limit of basically sine h by h as h tends to 0 times the limit of basically 1 over cos of x plus h times cos x as h tends to 0. So this becomes 1. And basically then you have, when h tends to 0, this becomes 1 over cos x times cos x is 1 over cos squared x. 1 over cos squared x. And you know that 1 over cos x is equal to secant x. This is secant squared x. Which means that d by dx of tan x is equal to secant squared x. So that is basically one thing that we need to use over here. Now going back to the same problem, we have basically we want to count now our f of x is equal to basically 2 times tan x minus 7 times secant x. Now f prime of x is equal to now they have calculated this based on the first principle, and I do the same thing as well. So I can write the f prime of x is equal to basically the limit of f of x plus h minus f of x over h as h tends to 0. As h tends to 0. And so basically, to make this simpler, I can write this as basically the limit of So you can do this part individually and then subtract from that this part, meaning that you can write the limit of basically 1 over h. This 1 over h, you can take it out up front, 1 over h, and then you can write 2 times tan of basically tan x plus h, tan x plus h minus tan x, because here you have basically f of x plus h minus f of x, and then you can write this as minus 7 times, for example, 7 times then secant x. So this becomes secant x plus h minus secant x, and then you're taking the limit of this whole thing, and I'm taking 1 by h out, so I put this in curly braces, and here I make h tend to 0. I make h tend to 0. And then what you can do is that now, of course, I'm supposed to write this up front. This 2 has to be written up right here. 2 times this. So I'm going to write this as so now if I separate these two parts, I can write this as the limit of basically 1 over the limit of, let me make this a little bit larger so I can see something. The limit of 1 over h times basically 2 times tan of x plus h minus tan of x, right? So that I can do, and minus basically the limit of 1h times basically 7 times secant x plus h minus secant x minus secant x, right? So now I have as h tends to 0. As h tends to 0. So you have the limit of 1 over h times this whole expression minus the limit of 1 over h times of this expression of this expression. And so this 2 I can take it out, and this 7 I can take it out, And then I can write basically tan of x plus h, I can write it as sine of x plus h over cos of x plus h. And tan of x I can write it sine of x by cos of x. Secant x plus h I can write it as 1 over cos x plus h. And secant x I can write it as 1 over cos x. So I write this as this 2, I can take it out, 2 times the limit of 1 over h times h tends to 0, h tends to 0 of basically sine of x plus h over cos of x plus h minus basically sine x over cos x minus 7 comes out, 7 times the limit of 1 over h as h tends to 0 of this expression. Now this expression I can write it as 1 over cos x plus h minus 1 over cos x and so then we can basically add these together, meaning that we can write 2 times the limit of h tends to 0 of 1 over h times basically cos x plus h times cos x, and then you will get sine of x plus h times cos x minus cos x plus h excuse me, times sine x minus 7 times the limit of 1 over h as h tends to 0 of basically cos x plus h times cos x and then over here you can write cos x minus cos of x plus h. Okay. Now, sine x plus h times cos x minus cos x plus h times sine x, that's the same thing as sine x cos y minus cos x sine y is equal to sine x minus y, which means that this becomes sine of x, which is x plus h, minus y, which is x, and then this becomes sine h. This numerator becomes sine h. So I write this as 2 times limit of 1 over h of basically sine h over cos x plus h cos x as h tends to 0, and the numerator here is cos x minus cos y, and cos x minus cos y is the same thing as is the same thing as cos x minus cos y is negative 2 times sine, right? So I can write that over here as well, meaning that I can write this as, so basically we know that cos x minus cos y is equal to negative 2 times sine x plus y divided by 2 times sine of x plus x minus y divided by 2. So which means that this becomes basically cos of x minus cos of x plus h is going to be equal to negative 2 times, now x plus y becomes x plus h divided by 2, which is equal to 2x plus h divided by 2, and x minus h divided by 2 becomes x minus h divided by 2, which is equal to negative h divided by 2. So then you have basically sine of negative h divided by 2, and of course you know that sine of negative h divided by 2, you know that sine negative x is equal to negative sine x, and so this negative and negative you can cancel out, and you can write it as negative 2 times sine 2x plus h divided by 2 times sine of h divided by 2. And that is basically this, actually this becomes a positive sign. So the basic expression here, negative 7 times the limit of h divided, h tends to 0 of 1 by h, and the 2 over here, I can also take that out, so I can write this as negative 7 halves. Or we can leave it there for now, because we are going to use it later. So I'm going to write this as basically, basically 2 times sine of 2x plus h divided by 2 sine of h divided by 2 over this expression, which is cos of x plus h times cos of x and then what we can do is that basically we need to basically write this as, so this h, this becomes sine h by h as h tends to 0, and that becomes 0, and then sine h divided by 2, and then I will use this h and add a 2 in the denominator, so that this becomes sine of h divided by 2, and that goes to 0 as well, as h goes to 1 as h tends to 0. And therefore, now let me actually do one of them one at a time. I don't know where I am in this solution. It seems that we are actually on the right track. So I'm going to write this as 2 times the limit of basically sine h over this h over here as h tends to 0, sine h over h as h tends to 0 times, and I'm going to just break this up into the limit of basically into the limit of basically 1 over cos of x plus h times cos x as h tends to 0 and well, the limit of sine h over h as h tends to 0 is equal to, this whole thing becomes 1, right? And then you will be able to evaluate this limit over here. Now, minus 7 times, now I can write the limit of sine h divided by 2, right? 7 times the limit of basically sine h divided by 2, and divide that by h, and then I needed 2 in the denominator. As well, as h divided by 2 tends to 0. As h divided by 2 tends to 0. As h tends to 0, of course, h divided by 2 tends to 0. And then you also have the limit of h tends to 0 of basically, and this negative, and this 2 is multiplied, by the way, by this whole expression. And this 7 is also multiplied by this whole expression. So, the limit of basically, now if I divide the denominator here by 2, that means that I have a divided by b, and if I divide the denominator by c being 2, I can write this as a times, basically a times c by b, which is the same thing as a by b times c. Meaning that I have multiplied, that I have basically multiplied the whole expression by a factor of c. So I have to divide the expression by a factor of c so that I don't owe the expression anything, and the expression doesn't owe me anything. Meaning that then I have to divide this since I have multiplied the expression by a factor of 2. I have to divide it by a factor of 2 as well. When I divide this expression by a factor of 2, this 2 is basically taken out. And so then that means that I have already taken care of this 2. I don't have to write it anymore. And so I have now the limit of basically, the limit of sine of 2x plus h, sine of 2x plus h divided by 2, and this already we have taken care of, cos of x plus h, and cos x as h tends to 0. Okay? Now in the limit, basically this becomes 1, and then this becomes basically as h tends to 0, this becomes cos x. Cos x, that's 1 over cos squared x. So that's 2 over, you have a 2 over here. So you have 2 over cos squared x. And then you have negative 7 times. So this part becomes 1. And then you have basically this part, sine of 2x plus h divided by 2 divided by cos of x plus h times cos x. So they have written this as basically as h tends to 0, this becomes 0. And so this becomes simply sine x divided by cos x is going to be equal to tan x. So over here you have a tan x. And then 1 over cos x, which is secant x. And so you have 1 over, you have basically tan x times secant x, and this is a 1, and you have a negative sign here. So you have negative 7 times tan x times secant x, and 1 over cos squared x is equal to secant squared x, so that is 2 times secant squared x minus 7 times tan x secant x. And that is the correct answer here. Okay. Now in the next video we will talk a little bit about some miscellaneous examples, so I'll see you in the next video. Thank you.